In the fields of material science, Mayo Kaku has, in fact, confirmed that the James Webb Space Telescope has identified 6 massive structures that experts previously believed could not exist. These observations have the potential to unlock new insights into how we may understand the universe. The discovery is both fascinating and gradually challenging existing theories about the formation and evolution of galaxies. Therefore, it is important to stay updated on these findings. The confirmation by such a distinguished authority emphasizes the importance of these revelations. Mayo Kaku is an extraordinary figure in the scientific community. A physicist of both American and Japanese descent, he is regarded as a specialist in traditional experimental materials science and quantum mechanics. Unlike some more conservative and controversial scientists, Kaku has embraced the astonishing delayed outcomes of the James Webb Space Telescope mission. His enthusiasm to accept new discoveries and share them with the public demonstrates his dedication to advancing our understanding of the cosmos. We are pleased that this esteemed researcher has decided to break his silence and openly share what can no longer be disputed. The energy and engaged tone of the renowned physicist are evident in his comments on the findings made by the James Webb Space Telescope, revealing that this discovery has sparked his interest. Join us as we examine the implications of Mayo Kaku's disclosure of these 6 colossal structures. Kaku is a scholar who has always been open to considering new theories. Throughout his career, he has shown a willingness to entertain ideas that challenge conventional wisdom, recognizing that Einstein's theories of relativity and Newton's laws, while essential, are insufficient to explain the full complexity of the universe. Kaku believes that the discoveries from the new telescope could potentially advance the field of cosmology. However, many of his colleagues have yet to accept this perspective. This has led to unease and skepticism among proponents of the Big Bang theory and critics of quantum mechanics. Nevertheless, this situation simply amuses Kaku. The JWST has revealed the discovery of 6 enormous galaxies dating back to the early stages of the universe. Each of these revered systems contains more stars than our Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The group of astronomers responsible for the discovery has dubbed these extraordinary galaxies universe breakers. Once confirmed, these findings could dramatically alter our understanding of the cosmos. The significance of these discoveries is immense, suggesting that the early universe was far more robust and intricate than previously thought, something that no longer aligns with current models. The theory of how the universe originated tells us that it was chaotic after the initial event. The first heavy elements took a vast number of years to form, and it took much longer for these elements to reach the necessary density and produce light. The emergence of complex structures like galaxies was assumed to occur much later. Some of the newly discovered galaxies even surpassed the Milky Way in size, and their immense luminosity implies they were likely forming new stars at a far faster rate than our galaxy does today. While our galaxy forms stars sporadically, the exact timing of the first galaxy's formation remains unclear. The only clear conclusion is that, in the beginning, there may have only been individual stars or groups of stars that later merged to form larger structures. Eventually, dwarf galaxies could have nurtured small vast galaxies that developed over time. The idea that enormous galaxies could exist so early in the universe raises the question: is the universe much older than previously acknowledged, or did intricate cosmic structures form much earlier than expected? This scenario is difficult for traditional science to accept, which still encounters challenges with this model. Some sectors of material science have categorically dismissed this finding and questioned potential errors in the age estimations. Kaku is aware of this and responded: "There are several outdated and misleading theories that persist due to the influence of certain experts. Many of these ideas were likely uncovered when thorough research exposed their flaws. Therefore, the key in any science, particularly in physics, lies in experimentation. Experimentalists keep scientists alert and attentive. In reality, on Earth, we have very little actual knowledge about the true origins of the universe." This statement from Kaku underscores the importance of continuous trial and error as well as validation in the scientific process. The theory of how the universe came to be was established in 1927 based on observations of the universe's expansion. This led to the conclusion that the universe began from a single, infinitely dense point and has been expanding ever since. At that time, it was nearly impossible for people and scientists to envision a universe with both a beginning and an end. The idea of an eternal, infinite universe was beyond human comprehension. Even today, researchers struggle to fully grasp it. However, it is crucial to entertain these possibilities, even if these new revelations do not align with long-held beliefs about the universe's origins. Science has repeatedly shown that revisiting and being open to new ideas is an essential part of the scientific method. Just as certain theories and observations were eventually accepted when Einstein was younger, it was once believed that stars and planets were immovable in the cosmos, and these objects occupied fixed positions. Today, however, we know that everything in the universe is in motion. Planets orbit stars, stars move within their galaxies at speeds of several kilometers per second, and entire galaxies move rapidly through space whose future we still cannot predict. This profound understanding of the universe challenges long-standing convictions and highlights the need for ongoing inquiry and evolution in scientific thought. Today, scientists are faced with the challenge of accepting uncomfortable truths and understanding that theories are not infallible pieces of knowledge until they are rigorously tested and confirmed by precise observation. The concept of the Big Bang emerged from the recognition that galaxies are receding from each other, and this expansion is proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe has been stretching over time. Factors such as cosmic background radiation and the redshift of light from distant galaxies, along with other cosmological patterns, seem to support this hypothesis. However, it's important to remember that in the past, people who believed the Earth was flat and that the Sun revolved around us also had observational evidence supporting their beliefs, until new discoveries or technological advances provided a clearer picture. We are now witnessing a similar situation. Scientists expected the new James Webb Space Telescope to confirm questions related to the Big Bang, but instead, they have encountered these 6 galaxies that appeared impossible. This illustrates that science is always evolving, and researchers must remain open to new discoveries and reconsider existing theories in light of new evidence. These extraordinary findings challenge current understanding and prompt a reassessment of well-established cosmological models.